Ooh.
Uh, yeah. So 9 over that stuff. Plus 9 over some closely related stuff. Whoa. Where should we start?
Oh, I don't really know.
Solve it.
Is it we're solving?
Yeah. What's the mystery?
What are we solving X? What are we doing?
Yeah. If you're asked to solve something, it's probably finding the value of a variable.
Oh, okay.
So you'd hope there's only one variable, and so there is. Just X.
Okay.
Trying to make X the subject eventually.
Yeah, okay. Oh, okay, so make... Okay. Well, wait, where would you... I don't know where to go with that.
Well, two big horrible fractions. Would it be less bad to have one big horrible fraction?
Yeah.
Okay. And how do we turn two fractions into one?
Add them?
Yes, and how do you, for example, add 2 over 3 plus 5 over 7?
You'd have to change the denominator.
Yes, and you would choose what would be a handy common denominator.
21.
Because it would be the product of the two denominators.
Yeah.
Yeah. So you turn 2/3 into how many 21s?
14.
That's right. Before worrying about the other fraction. So similarly here, let's turn the first fraction into what? Denominator instead.
What? Put them in brackets and expand them? Maybe?
Well, yeah. One thing at a time, though. Why did we choose 21? Because it was 3 times 7.
Yeah.
So what should we choose here?
What they are.
Yes.
What they
times together. Yes.
So 100.
But don't be in a hurry in algebra to give a later result.
Okay.
Okay, we did say 3 times 7, but we didn't have to. I could have written, let's first of all have 3 times 7 here, plus 3 times 7 here. And then we could still have said, okay, on top, we're going to have 2 times 7, which is perfectly true.
Okay.
41. Maybe that's a better model for what we're going to do here.
Okay, yeah. So you
first fraction becomes
it becomes 10 minus x.
Yeah.
And then times by 10 plus x. Yeah.
Exactly. We don't have to be in a hurry to expand.
Mm-hmm.
And on top?
And then, well, for the first fraction.
Yeah.
Oh, would it be 9 times 10 plus x?
Yes, it would. Good.
Okay.
And then for the second fraction?
It would be the same.
Same denominator.
Yeah.
Yeah.
And then for the numerator, it would be 9 brackets 10 minus x.
Yeah.
Okay.
Okay. So have we finished on this line, or?
Equals 5.
You got the idea, yeah. You're rewriting the whole sentence.
Yeah.
So let's complete the sentence. Good. Now what? I think you know what next, because you said, in a way, you might have been surprised or bored that I wrote it in 2 fractions still. You seemed aware we could bring it all together into 1 fraction.
Yeah. Okay, so on the bottom you have 100.
Yeah. Okay.
Well,
I mean, let's do. Yeah. I'm just going to be lazy, or a bit more careful, and let's show the stage which is bringing these together into one fraction.
Okay.
In fact, just to be extremist about it, let's just write the numerator exactly like that without expanding anything. But you might not have bothered to do that, I agree.
Okay.
And now you're saying you'd like to expand the bottom.
Yeah.
I mean, yeah, maybe. It's up to you. I don't know whether it's going to be worth it or not. I think the numerator definitely wants expanding.
Okay, let's do that then, I guess.
Actually, we are going to eventually want to expand the bottom as well. So I don't know why.
Okay.
Fine, carry on. Yeah.
Okay, so for the first bracket, well, the first one, you'd have 90 plus 9x.
Yeah.
And then plus 90 plus minus x. Right?
Minus 90 plus
X.
minus
9x.
Yeah.
Oh, yeah.
Yeah.
Yeah. Oh wait. So
I mean, you said
does that mean
minus, and I said minus. Same thing.
No, but for the first one, would it be plus 9x? Like 90 plus 9x.
Did I miss that one?
I think so.
Thank you. Right. 90 minus 9x. Right.
Okay, and then on the bottom it would be 100 plus 10x.
Yeah.
Minus 10x.
Good.
And then oh wait, where have I gone? Oh yeah, okay. Minus x times x. Oh, minus x squared. Minus x squared.
Minus x squared. Correct. Yeah. Good.
Equals 5.
Equals 5. Good. Yeah.
And then those would simplify to 180.
Yes. Yes. Let's simplify. 180.
Oh, then that's it. Yeah. Over minus x squared. Oh wait, actually. Yeah, minus x squared.
Yes.
Plus 100. And then yeah, that's it.
And that's it.
Yeah.
So shall I write minus 100? Sorry. Shall I write minus x squared plus 100? Or
you could put 100 minus x squared.
I could write 100, and then I lose the minus sign. We tend to like to lose the minus sign if we can, don't we?
Equals 5.
Lovely. Next.
Now, I don't know. What we do now?
Well, okay. All right. So let's zoom out a little bit. What are we trying to do? Solve for x.
Yes.
So we're trying to solve the mystery of what x is. And so far, what have we done? We've turned 2 horrible fractions into 1 much nicer fraction.
Yep.
So what would be nicer than 1 fraction? If 1 fraction is better than 2 fractions, what's even nicer than 1 fraction?
No fractions.
No fractions. Can we remove the appearance of a fraction?
Times by 100 minus x squared.
Yeah. So what should we write on each side?
So 180 equals...
Sorry. That's very rude of me. I had a biscuit.
It's okay.
It's okay. Eating while I'm just trying to talk. I wouldn't have dared do that. Right, so, sorry, what am I writing?
Sorry, 180.
Yeah.
Equals...
Yes, good. So
5.
Cancelling the dividing on the left.
Okay, yeah. Equals 5. Would it be plus or bracket? Yeah, bracket. Yeah,
because you multiply
100.
You?
Yeah.
Yep.
100 minus x squared.
100 minus x squared. Good. Nearly there.
And then would we expand that bracket?
Yep.
Okay, so 180 equals
Yeah.
500 minus 5x squared.
Yeah.
And then you could minus 500 from both sides?
Yeah.
Or
I mean, what would be a little bit quicker would be to say, I mean, eventually we want to be writing x squared equals stuff.
yeah. Oh, okay, so
x
plus
equals stuff. So maybe we could say, we could put 5x squared on the left, couldn't we?
Yeah.
And now you could either think of that as adding 5 to each side and subtracting 180. Yes, you could think of it like that. Yes.
Yeah.
Okay, so on the right-hand side?
Yeah, equals 500 minus 180.
Yeah, which is? Notice that when you're balancing in algebra, you generally do that. You don't leave little bits of, I mean, you don't give a signal, which you are encouraged to do at first, which is give a signal of, you know, what it is we're doing, you know, adding 5x squared and whatever. We tend to leave that out and just, you know, give the result of it. 100 minus 180 is?
320.
Lovely. In which case?
And then, divide by 5.
Yeah.
So yeah, x squared equals 320 divided by 5.
And dividing by 5, the easy way to do it is to divide by
10, then half it?
Kind of. Be careful. Notice which do you want, a smaller result or a larger result than dividing by 10?
You want a smaller? Smaller?
I think dividing by 10 gives you a smaller result. Don't you?
Oh.
Because you're sharing between more people.
Yes, okay. So divide by 10 and double it?
Absolutely.
Okay.
Very handy little trick, that, isn't it? For dividing by 5 or timesing by 5. And there are some related little tricks to that you'll discover as well. Anyway, x squared therefore equals divide by 10 and
that equals 64.
Lovely. And therefore x equals
square root of 64. So 8.
So 8 or
the square root of 64.
Yeah, I mean the square root of 64 is 8, or what else is, what other square root? What's the other square root of 64?
I don't know.
What other number squares to make 64? 8 is one number that squares, multiplies by itself to give you 64.
Yeah.
What other number multiplies by itself to give you 64?
32. Does it? No, it doesn't.
That doubles to make 64. That's different. That's not multiplied by itself, is it? That's just multiplying by 2.
Yeah. So.
Yeah.
I don't know. How do you?
You'll kick yourself. It's a very close friend of 8.
It's not 4. I really don't know.
A close but maybe evil twin of 8. A close relation. Almost the opposite of 8.
Oh, mine is 8.
Yeah.
Oh.
Remember when we take a square root?
Yeah.
That's why we generally write, as you'll have found in your quadratics work, you take the square root here and you have to put plus or minus.
Yeah.
Not root 64 or 8.
Yeah, okay.
So 8 and minus 8 That's another way to write the answer. You could say x equals -8 or 8.
Mm-hmm.
That would be the other way to say the same thing. And yes, then we've solved that. We found out what x is. We could check that, see if it's true, couldn't we? Supposing it's x is +8, then this would say what?
10 minus 8
is
2. Oh, 2.
Yes, so
And
here
then,
we've got 9/2, haven't we?
Yeah.
Which is how much? What's 9/2 as a mixed fraction?
As a what? Sorry?
As a mixed fraction or a mixed number.
Oh.
What's 9/2?
9/2
Or a
is
decimal. Sorry?
4
and
1.5.
4.5. In other words,
Yeah.
4.5. Yeah, good. And then 10 plus x would be
18.
In which case, 9/18, which is, in other words,
9/18 is 2. Oh, wait. As a mixed number? Wait.
Well, actually, no. As a fraction, what's 9/18? Just simplified.
That is what, a half?
Yes.
Yeah.
Okay, and this is telling us to add them together. That fraction, which is 4.5.
And then
plus this, which is a half.
Another. That is 5.
That is 5, so it works.
Yes.
Yeah, so we know that's right. Let's try it with -8. What's 10 minus -8?
18.
In which case here we would have the half, 9/8.
Yeah.
And then here we would have 10 plus -8 is?
That's 2 again.
Giving us
again.
Again.
Yeah.
Nice. So it checks out from every angle. Right, good.